Section 8.1. We're going to start out talking about square roots, and square roots are the most common type of radical that we use, and a square root is used to unsquare a number. I mean, that's a made-up word. Unsquare is not really a word, but it unsquares a number. Okay, so for example, we know that 5 squared, or if we think about it, we know that 5 squared is 25.
You're recording this?
It is recording. I'm going to check or double check. It is recording. We know 5 squared is 25. So we can say that the square root of 25 is 5. Okay, and the question it's asking is, what number times itself would equal 25? Well, we know that's 5. Okay, because 5 squared is 25. The way we write a square root of 25, we write it this way. You do this square root sign. It's also called a radical sign. And you have the 25 inside. And then if you saw this, that would tell you what number times itself is 25. And your answer would be 5. Okay? And most of you will have a button like this on your calculator, but it's not all just going to be these numbers, and your calculator won't always do it. It'll do it on easy ones like this, but not on everything. Okay? Because not everything comes out evenly. All right, so some examples. The square root of 1 is 1 because 1 times 1 is 1. The square root of 4 is 2 because 2 times 2 is 4. 2 squared is 4. The square root of 9 is 3 because 3 times 3, or 3 squared, is 9. Then to some bigger ones, the square root of 121 is 11 because 11 times 11, or 11 squared, is equal to 121. Okay, and all of these are ones that come out nicely, come out evenly. And then 625 is a big one. You probably want a calculator for that, but I'll show you how you can break it down and simplify it even without a calculator if you're not sure. But it ends up being 25 because 25 times 25 is 625. Now, negative 81, the square root of negative 81 is what we call undefined. And later on, not this semester, but when you take college algebra, you're going to find out that this is actually called, it doesn't fit into the real numbers. We talk about our numbers way back at the beginning, and you've got like integers, which means no decimals, no fractions. You've got rational numbers, which is fractions. You've got whole numbers. You've got all these different types. And then you've got the real numbers, which is pretty much everything you've probably ever talked about in your whole life is real numbers. Okay? This square root of 81 is not, square root of negative 81 is not a real number. This book calls it undefined for now. It's undefined in the real numbers because there's no number that when you multiply it by itself, you get a negative 81.
It wouldn't be negative 9.
No, because what is negative 9 times negative 9? Positive 81, right?
What about
Yeah, so any number times itself has to end up being positive or 0 if it's 0, right? Because a negative times a negative is a positive, and a positive times a positive is a positive. So there's no way to get this. Does that make sense? So we're not even going to worry about dealing with negatives inside of here when we're talking about square roots, because it's impossible. Okay, using real numbers. So our final example, that square root of negative 81 is not a real number since negatives have no real square root. There's no number times itself that will give you a negative. There's no real number times itself that will give you a negative answer. And then again, that's just the explanation we've already talked about. That's because if you square a positive number or if you square a negative number, the answer will end up being positive. So there's no way to get a negative. All right. Unfortunately, not all numbers are like those examples that we did. Not all of them have nice, even square roots. So for instance, if we took our calculators and we typed in the square root of 8, which is close to the square root of 9, right? Square root of 9 is 3, but the square root of 8, what times itself equals 8? Well, it's not a nice number for us. So it ends up being a decimal, and we would get all these decimal points. Your calculator maybe would go roughly to about there, I'm guessing. But if you kept going, these numbers just keep going forever and ever. Okay? So, and that number, even this far, is still rounded off. It's an approximation. This is a type of number that actually goes on forever and ever and ever and ever, and the decimals never stop, and they never start repeating for us. Okay?
What's the thingy on the calculator?
Oh, good question. So it's gonna be a button that looks like
I
this.
think I see it, but how do you, is it second and then that?
Yeah, it's gonna be, usually it's by the x squared button.
Yeah.
So it'll be second and the x squared button will give you this, and then you put your 8 after that.
So you start with second.
Yep. And again, each calculator is a little bit different, but I think all four of you guys have the same type. And did you get something really close to this?
1.03.
No. Let me see. Oh, it's because, okay, you hit this one second.
Yeah.
This one, you need to use second and the square.
Oh.
So try that again, but just use the second and the square. Were you guys able to get the 2 point whatever?
Mhm.
So you're going to do second. Square.
Do you close the parentheses?
I suggest that you do. It actually won't matter in this case, but it's a good habit to get into when they open a parentheses. Go ahead and close it.
Okay.
Brenda, Sergio, were you guys able to get the 2 point, whatever that is, 8, 2, 8?
I didn't, so equal 8.
So, no, you're going to put in your square root sign first, so second squared, and then you'll put in your 8. And you don't even have to close the parentheses, like I said in this case. Were you able to get it?
Yeah.
Okay. And you got it?
Mm-mm.
No? Okay, so yours is going to be that button, so you'll just push that button and then put in the 8. Oh, so yours is actually simplifying it. Big cheater. Okay, so anyway, it's going to make your life easier later on. And I think
What kind of calculator do you have?
if you, there's a button if you wanted to get the decimal point, but it's not going to matter. So you're going to make sure you learn how to do it, because when we do variables, again, the calculators won't do the variables. So you've got an advantage on the numbers, but it won't work for the variables. So anyway, to be as accurate as possible, to keep an exact answer, we will express these roots using simplest radical form, it's called, which means we're going to break these things down as much as we can, and we will still have usually something inside of that radical sign, but then as much as possible, we're going to get everything else out of the radical sign. Okay? So that simplest radical form is that after we've simplified the radicals as far as we can, we call that simplest radical form. And we're going to do some examples to show you how you get to simplest radical form. Now, if everybody's ready, oh, did you have to fill in a blank? Simplest radical form. I see it's blue there. So. Okay. So here is the product rule for dealing with square roots. If you can break inside your radical, if you can break it up into 2 parts, you can actually split it apart into 2 separate radicals, and sometimes that means you can simplify something. And again, we're going to use this in a little bit to help us out. Okay. So for instance, here's our first example of this. We're going to write this in simplest radical form. So what we want to do first is we want to use prime factors to break up the 75. Okay. So 75, how can we start breaking up 75?
Divide by 5.
Okay, so 5 times, it ends up being 15. You can just use a calculator, just 75 divided by 5, and it'll give you 15. And then how can we break up the 15?
3.
So 3 times 5, right? So that means 75, we can break it up into 3 times 5 times 5. Does that make sense?
So you started with 3 because it's the smallest one?
Yeah, I just put them in order.
It didn't matter?
No.
Or do you?
It doesn't matter. Usually if you go back to when you used to do prime factorization, usually they'll have you write it from smallest to biggest, because then there's only one way you can write your answer, and it just makes it easier to work with. So we've got this. Now what we're going to do is we're actually going to split this up. Remember how the property here says we can split this up? And I'm going to put the 3 in the first parentheses, or not parentheses, but radical. And then I'm going to put the 5 squared. Does that make sense if that's actually 5 squared in the second one?
Do you have to put it like 5 squared, or can you do 5 times 5?
You can do 5 times 5.
Let's do 5 times 5.
That's fine. Oh, you want me to do it up here 5 times 5? Oh, okay. Well, so sorry. So 5 times 5.
Mhm.
Now, what happens is when you have this pair of 5s like this, what do we know that 5 times 5 equals?
25.
25, right? So just over here to the side, and I'm not going to do this every time, but I want to show you kind of the thinking process. If we've got 2 of them, 5 times 5, we know that is 25. And what did we learn earlier tonight? The square root of 25 is? It's 5, right? Square root of 25 is 5 because 5 times 5 equals 25. So what happens is anytime you have a pair like this, the pair is going to turn into 1 and the radical is going to go away. So the weird name that we have for this at the high school is that it's called the jailbreak method. So as long as you have a partner in jail with you, you can escape. Okay, you can escape from the jail. So the 5 comes out. Now, I don't know what happens to the other partner, but somehow he disappears. Okay, but 1 5 gets out, and then we still have the 3 right here. The 3 has to stay in. It is not able to get out of jail. It doesn't have a partner. Okay, so this, and again, what this means is 5 times, we don't usually put the times sign there, but it means 5 times the square root of 3. Just like these were still multiplied together, these are still multiplied together at the end. Okay, so anytime you have a pair that match up, that's going to be able to come out of the radical. Okay, and this is an example of simplest radical form where we get as much out of the radical as we can, and then whatever's left, we just leave inside the radical. Okay, so that's one example. Now again, the reason that happens is because when you have a pair, if you actually think about what that equals, it's always a perfect square, and you'll always be able to simplify. So this will always turn into this, regardless of what these numbers are. So if this was, separate example, if this was square root of 7 and 7, we know that's going to equal 7, right? So this, inside the radical, this pair will always turn into that.
Okay, so if you have 2 pairs, so you combine them, like you do the same thing again.
If you had,
2 pairs.
so give me an example.
Like
Oh, okay, so let me see if I understand what you're asking me. I think I know what you're asking me.
you have 5.
So if you have a 2 and a 2 and a 5 and a 5,
Yes.
okay, yeah, the 2 comes out and the 5 comes out, and then you still multiply them together, so it'd be 10.
Okay.
Oh, so you multiply.
Yeah, because these are all multiplied. These will still be multiplied. Okay, we're not dealing with.
Just by 1, 2 times.
Yeah, we're not going to be doing any adding today yet. I don't know. That's going to be next week. I get the rolling of the eyes just because I say the word addition. Okay. All right. All right, so the next one, 5 times the square root of 63. So again, the first thing we want to do is let's go ahead and break up the 63. What can divide evenly into 63?
Is it 7?
7 can? How many times? 9. And then 7 is prime, but 9 can break up into
3.
3 and 3. So here's what we have. We have.
Hold on, can you slow?
Oh, yeah.
down? Sorry.
It's okay.
3, so 7. Why'd you put equals 5?
Well, he told me to stop. I'm not done.
Oh. Oh,
So,
sorry.
we still have the 5,
Sorry.
and then we have our radical, and then inside the radical we have a 3 and a 3 and a 7, correct? From what we broke it down. Now, because of these 2 3s, what does that mean we're going to be able to do?
Just use 1 3.
Take out a 3. So we still have the 5 in the front, but now we have a 3 in the front, and then we still have the 7 on the inside. Is everybody okay with that? So the pair of 3s, it can escape, and you have a 3 on the outside. And then, I mean, you just do the math. What does this mean that we're supposed to do? It's multiply, right? 5 times 3. So we're going to get 15 on the outside, 7 on the inside. So that would be our simplest radical form.
No, it's 7, that's Sally. Sorry, Sally.
Okay. Does that make sense? Okay. Are we able to go on?
I think.
Think so? All right. Well, let's take a look at it.
15, how do you say? 15 square root 9.
15 squared or 7.
Okay.
I mean, you can say 9, but that's not a 9. It's a 7.
So. for the
15
test-
squared of Sally.
For the test, can we use that little graph that the elementary kids use? With little squares, and you can find your,
What?
You mean for this?
yeah.
What? Elementary school.
You mean the like the multiplication
Yeah.
tables?
Because you can find your little, what's, you know.
Oh, what
Yeah.
times what is
Yeah.
whatever?
Yeah.
Even
No, you have a calculator. You
calculator.
can use a
You
calculator
You
for
even
that.
give the calculator, so that's in the site.
Yeah, you can use a calculator.
So no.
You just start checking.
You can use.
No, you don't need a you don't need a factor table.
Yes, I do.
No, you don't.
That's how my brain functions.
Okay, well, think of it in your mind and then use your calculator to figure it out. Okay, 72. 72, we're going to break up the 72. There's nothing on the outside this time. What can we multiply? What can we break the 72 into? Now, if you're not sure, now you
Yeah,
said 9
that's
and
right.
8. 9 and 8 is fine, and it does work. But let's say that you're not sure.
8 times 9.
It's even, right?
Yeah.
So we know 2.
2. Okay.
So you just divide and you get 2 and 36. Does that make sense? And then how can we break up 36?
2.
Okay, 2 and 18.
Oh, you just kind of, okay, I get it.
And then 2 and 9. And then 3 and 3. So you can start small. You don't have to get the biggest and best first. You just need to find something that will
But we
go
have to use
into.
all those big all those little numbers if we don't, you go big.
Well, even if you go big, those bigger numbers will eventually break down into
Oh.
these little numbers. So it doesn't matter really what order you do it in. You just have to eventually get here. So 72, we just found out is 2 times 2 times 2 times 3 times 3. Does that make sense? And what does that tell us? Is there anything that we're going to be able to take out?
3 and a 2.
1, 2, because of the pair, and then because of the pair of threes, a 3. So we're going to take out a 2, we're going to take out a 3, and then we still have what on the inside?
2.
2.
A 2 is still stuck on the inside, right? It doesn't have a pair.
No, sir.
So then we simplify on the outside. 2 times 3 is 6. And 2.
That's the answer.
That's our answer. Now, I do want to show you one thing, because this may come up later or may not, or different people. If you watch a video on any of the lessons, it may show you something like this. But let's say that we stopped right here, and we had 2 and 36. And remember that allows us to break these up. Do we know what the square root of 36 is?
6.
It's 6, right? So if you see that earlier, you don't have to keep breaking it down. You can take the square root of 36 right away if you want to.
But we can keep going.
But yeah, you can just keep breaking it down. Okay? But for instance, if I was doing these, and I've been doing these for a long time, just as a time saver, I would look for perfect squares that go into 72. Okay, but you don't have to. You can always use this method that I've shown you. So no big deal. That's just a little bit of a shortcut if you want to try it. Okay? Well, let's take a look though at this one.
Oh, that one looks.
It looks scary, doesn't it? Now, in our mind, we're going to do some visualization, but we're going to start with the 18. We're going to break up the 18. How can we break up 18?
2 times 9.
2 times 9, and then 9 is
3 square.
3 times 3. Now, again, I'm not going to do this every time, but I am going to do it this time so that you can see what's going on. So we have a -5. We have a 2 and a 3 and a 3. Then how many x's do we have?
4.
4. 1, 2,
square
3,
root.
4. How many y's do we have?
6.
1, 2, 3, 4, 5, 6. Oh no. And how many z's do we have?
And
10.
Oh
1,
my.
2, 3, 4, 5, 6,
7, 8, 9, 10.
All right, got it.
You can have
Whew. So we're looking for pairs, right? So let's start with the numbers. We need the 5 on the outside. What else do we have? We have a 3. So we can take out a 3. Then let's look at the x's. Well, notice we have
S squared.
2 pairs. Does that make sense?
Mm-hmm.
So we can take out 2 x's. Before I go on, does that make sense with the x's?
Yes.
Everyone's staring at their papers. They're like, if I don't look up, maybe it won't go on.
no, I'm trying to copy everything.
Okay.
Okay. Yes, that makes sense.
So then we go on to the y's, and notice we have 2 y's, and 2 more y's, and 2 more y's. So we can take out a y, another y, and a third y. And then what about the z's?
6.
You got 5 pairs, right? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then what's left inside the radical?
Just 2.
Just a 2. So we do not want to write it this way because this would take a lot of space. But we multiply. Negative 15 is the number part. It'll be x to what power?
Square.
Squared. And then y to what power?
3.
Third. And then z to the fifth. And then you have the square root of 2 on there. Okay. Now, again, I'm not going to write out all the x's, all the y's, and all the z's every time. But here's what we're going to think of, right? We know we have 4 x's. And we can visualize 4 x's in our mind, right? And if I know I need pairs, and I've got 4 of them, how many pairs am I going to have? 2. If I've got 6 x's and I need pairs, how many pairs will I have? 3. If I have 10 z's and I need pairs, how many pairs will I have? 5. You're dividing, right? 4 divided into groups of 2, divided by 2. 6 divided into groups of 2, 10 divided into groups of 2, right? So what you do in a case like this, as a shortcut, you could write them out if you wanted to, but you can take the exponent and divide by 2. And that will tell you how many x's you'll have on the outside. Now, these were all even, so it was really easy, right? But sometimes you'll have some x's and some z's or some y's left over, and we'll look at that as well. Okay, so does that, yeah, that bottom one is the answer. Does that make sense? Okay, let's try another one. Here we've got some odd exponents, but let's see what we've got. Okay, let's start out with the 20 again. Let's deal with our number. How can we break up the 20?
2 times 10.
2 times 10, and then
2 times 5.
2 times 5. Okay, so we have 2 times 2 times 5. And then I'm just going to leave this as x to the 5th. And y to the 9th, and z to the 6th. Okay, I'm going to leave it there for now, and we'll see how you guys like this. Numbers. What number? We can take out a 2, because we've got a pair of 2s, so we can take that out. The 5 has to stay inside. Now, if I have 5 x's, how many pairs of x's will I have?
2.
2 pairs. But, and I'm going to put this over here for now, how many x's will still have to be inside?
1.
Does that make sense? You've got 1 left after you take out your 2 pairs. Okay. If I've got 9 y's and I need pairs, how many pairs will I be able to take out? 4 pairs. And how many y's will be left over inside?
1.
Just 1. Because we took out 8 of them, right? Or we used 8 of them. And then if I've got 6 z's and I need to take out pairs, how many pairs of z's will I be able to take out?
3.
3. And how many will be left inside?
None.
None, because we used them all. Does that make sense? And can we kind of visualize that as we're thinking about those pairs? And so, is there anything else that we can simplify?
No.
No. Everything is just one number on the outside, one number on the inside, and then one of each variable.
What is that? My eye cannot see.
Which part are you looking at?
S squared, y 4, 2.
Z, that's a Z. Z cubed.
You don't want the times in between, right? You just want them together. But
Yeah,
if
if there's no symbol in between, it automatically means times. If you put the time sign there, that's fine. It's just, it doesn't need to be there.
Okay, so
And in fact, sometimes when they give you the answer, like after you're done, it will show a time sign there. But it's automatically there, but you don't have to write it.
why not?
Can I request something for the study guide?
I'm sorry, what?
Can I request something for the study guide?
Okay.
If-
What study guide are we talking about?
For the study for the test, not the final, but this
Okay.
chapter 8. So like, just leave the same question, like the same problem.
Oh, on there.
because
What
they-
is it set up as?
Just one time.
One chance?
Try a different
Okay.
one.
Can you email me so I remember to
Yeah.
change it? Because I might say yes right now and then go home and forget because, you know, Thanksgiving.
Because that helps me in the
Yeah.
test, 'cause
No,
Otherwise,
I
don't
thought
know
I
if
had changed some of those, but I know I changed all the homework, but I maybe didn't change the study guide
Okay.
review. Okay,
Can
did
you
you,
explain me again that X, Y, Z?
these, are you okay with the Z?
No,
No?
I'm okay with the number. 2, 2, 5, I'm okay. X, Y, Z, I'm not okay.
Okay, so if you think about what we've got there, x to the fifth is 1, 2, 3, 4, 5, right? So we've got 2 pairs. So that's what comes out. And then you've got 1 left over that has to stay inside.
So think about that. Yeah, I got it.
So it's like dividing. If you take 5 and divide by 2, you get 2 with a remainder of 1 left over, right? So here's your 2, and here's your remainder of 1 left over. Same thing with 9. If we divide by 2, it's 4 with a remainder of
What?
9 divided by 2, right?
Mhm.
Okay, so if we think about 9y's, so 4 groups of 2 with 1 left over. And so there's your 4 groups of 2 and your 1 left over.
Okay.
And then the z's, there's 6 of them.
I don't see in my eye. I have to write it down.
And so you've got 3 groups and there's none left over in the inside.
Okay.
But again, the little bit of a shortcut is actually just to think division. So 5 divided by 2, well, it's 2.5. It's 2 with 1 left over. 9 divided by 2 is 4.5. It's 4 with 1 left over. 6 divided by 2 is just 3. So you've got your 3 and none are left over. Okay? Does that make sense?
Yeah.
Okay.
We're gonna get really hard after this.
Really hard? Well, if you can understand what we're doing now, you're in good shape, at least for tonight. Well, I mean,
Yeah.
okay. Now 8.1 and 8.2, as far as the assignments, they are together. So it's just one assignment that has 12 problems that will be due next week, next Monday.
Let's do them.
Section 8.2, higher roots. It just means bigger than square roots. So we didn't talk about this, but because it's automatically written. But when we see this symbol, there's a number actually right here that's automatically there, and it's a 2. Because we're looking for what number multiplied by itself, so 2 of them equals 9. We also have the same type of thing with a number here that's not a 2. If there's a number there that's not a 2, if there's nothing there, it's understood to be a 2. It's one of those things that we just know. If there's nothing right there, it's automatically a 2. Well, if there's a number written here, then we're not looking just for a pair. We might be looking for 3 of them, or 4 of them, or 5 of them, or whatever. So if there's a number written here by this radical, we actually call that number an index. This is called the index. And it tells us the index of the radical. And so corresponding, what that means is, so if we say the 5th root of a equals b, that would mean b to the 5th power has to equal a. Just like when we were saying the square root of 25 equals 5, so 5 squared equals 25. So this automatic 2 goes with this 2. So we could say the same thing. We could say the cube root of 125 is 5. So 5 cubed is 125. Okay, that index and that exponent go together. They match up. Okay? And what this means is 5 times 5 times 5 equals 125. That's the relationship there between those two. Okay? So let's see how all of this works. So the small letter m outside the radical is called the index. It tells us which root we are taking or which power we are undoing. So square roots, the index is automatically a 2. So we've already kind of mentioned all that stuff. So again, just some examples here. And I actually just use this one. The cube root of 125 is 5, and that's because 5 cubed is 125. The 4th root of 81 is 3, and that's because 3 times 3 times 3 times 3 is 81. These get big really fast when you're doing powers. The fifth root of 32 is 2, and that's because 2 times 2 times 2 times 2 times 2 is 32. Okay? Now, here's something interesting. The cube root of negative 64 is negative 4. Now, here's why that's okay. If you take negative 4 times negative 4 times negative 4,
Oh,
3 negatives,
yeah.
you can get a negative number.
Yeah.
Does that make sense?
Yeah.
So the cube root of negative 64 is negative 4 because negative 4 raised to the third power is negative 64. Same thing here. The seventh root of negative 128 is negative 2 because negative 2 times negative 2, 7 times is negative 128. But if we go back to this one, the fourth root of negative 16, again, that's not real. And the reason it's not real is think about how many numbers we're looking for. I need 4 of them, right? And if I try to take negative 2 times negative 2 times negative 2 times negative 2, and there's 4 of them, that's going to end up being positive.
So anytime they're odd,
Exactly.
you can say,
Good eye. So what are we saying? Say that for us.
I forgot.
Oh, you forgot.
No, so if
Anytime
it's odd,
that
if it's an odd number,
Yeah.
then you know it's going to be.
if it's an odd index, the negative doesn't matter. It's okay.
Mhm.
If it's an even index, we can't have a negative inside here. Okay, because there's no way you can put together an even number of numbers and get a negative answer. But you can put together an odd number of negatives and get a negative answer. Right? So how do you do this on a calculator? Because I do want you to know this, so you can actually check every one of these. Here's what you have to do on your calculator. You have to put in the index first. So let's say we're doing, let's just do this one. You would have to write down your 7 first. And then for most of you, you're going to use your second. That's an S. I don't want to write out second. You're going to use your second and then the caret symbol button. And if you look at that button, it's going to have, usually it'll have something like an X and then a Y inside or something like that. Or it may just have the X and nothing inside. But what your calculator will do is it'll do this most of the time. And then you'll put in your negative 128 and then
In
close it.
parentheses.
And then I think, does it put the parentheses there already? You will want to put the parentheses there probably.
We do the second first.
So you do the 7 first. You do the index first, and this tells it that that's the index. And so double check that. See if you're able to get that negative 2 when you type that in.
I was going to take a screenshot of the calculator.
For why?
That was myself.
Oh, 2. Okay. Were you able to get the negative 2?
Yeah.
Okay. Everybody able to get the negative 2? Were you able to get it?
Mm-mm.
No? Okay, so yours may be a little bit different. So you're going to use... Okay, you're going to use second and this button right here. So, or shift, and then this button. And then you're just going to put in the number here. So now you can put in the 7 for the index up there.
Oh, okay.
And then you can just move your arrow over, and then you can put in your negative 128. You may have to put in you can try it, see if that works. Oh yeah, it does work. Sometimes calculators like you to use this instead of the minus sign. Some of them will freak out. So, okay. So you're able to get it now? Everybody, you weren't able to get it? Okay, so show me what you typed in.
You said put second. This is it.
Actually, you're going to put in your 7 first. So you're going to put in your 7 first, and then second. And then you're going to have to do. And what I would do is I would put in the parentheses. Oh, wait. Did we hit enter already?
Yeah.
So go ahead and put in your 7.
Mhm.
And then second. Caret symbol. And I would put in parentheses, but put in your negative. And then the 128. So you might want to make a mental note of that because it's just something that you want to know how your calculator does these different things. Okay, so that is just several examples. Was everybody able to get the negative 2? Anybody that was not? Brendan, did you get it? And
Hold on,
Sergio, did you get it?
I didn't get it the second time.
You didn't get the second time?
7 second. Yeah. And then parentheses negative. don't know what I did, but yeah, I got it.
If you use a minus sign, sometimes the calculators freak out if you use a minus sign instead of a negative sign, because they treat that differently. Did it give you an error message, or did it give
Yeah.
you? That's probably what happened then.
That's what it was, okay.
Yeah. Because they treat the negative, some calculators, like hers didn't. Hers treated the negative and the minus sign exactly the
It
same.
has the $500 effect.
No, that's not it. That's probably a what, 20, 15, 20,
Walmart
10?
10.
It's in the $10 to $20 range probably.
Okay.
But the TIs, their programming on the TIs, which a lot of, even the $100 calculators, they have the separate minus sign and negative. And if you put in the wrong one, the negative, it thinks you're multiplying by a negative number. The minus sign, it thinks you're subtracting. So it does it differently. These are evidently programmed in such a way that it doesn't make a difference.
So
So-
at the test, we can use a calculator.
Of course,
Get the
Sally.
answer. To get the
Or
answer,
we can
we have
bring
to
her-
press it, right?
Well, I'm not going to probably give you too many that are just like type into the calculator. I'm going to want you to break it down like we did in the, it's a
job.
simplest radical form like we did in the, when we were doing the last lesson. So again, notice that it is possible to find an odd indexed root of a negative number. It has to be an odd index for that to work, but not possible to find an even indexed root of a negative number. Okay, and we had already talked about that. That's why the 3 and the 7 are okay to have negatives. The 4 for the index is not okay to have a negative. And it's always odd is okay, even is not okay.
Okay.
Okay. All right, we have the same property. See, this is the exact same property, right? That we had before. We're able to break it up, and that just allows us to break things up. So write the simplified radical form of this. So we're going to do the same thing. 54. We're going to break up the 54. How can we break that up? 2. And you can use your calculator. It's okay. But it ends up being 27. So how can we break up the 27?
7.
Not 7. 28 would be 7.
Oh, yeah. 9.
9 times 3. And then how can we break up the 9?
3 squared.
3 times 3. So here's what we have. We have the cube root of 2 times 3 times 3 times 3. Now in the last lesson, 8.1, we were looking for pairs. The reason we were looking for pairs was because the index, even though we didn't write it down, the index was a 2. So this time, we're looking for a group of 3. So notice what we've got. We've got a group of 3. So that allows us to take out a 3, and then the 2 is still on the inside.
You keep the little 3 there in the corner?
The 3 has to stay there because you don't want to change that index because then you're changing what it's saying.
Oh.
So we want to make sure it says we're taking the cube root of 2.
And the calculator should be there?
You'll have to put it, like if you're evaluating, you'll have to put that 3 in with the caret symbol, the second caret symbol, just like we did with the 7. Does that make sense? So if you wanted to figure out as a decimal what this was, you would do 3 and then times, and then you'd have to do the second button and then the caret symbol button, and then you would put in your parentheses and your 2. And then it would give you, I mean, you could actually do that from here. If all you wanted was a decimal, you could actually just do it right here.
Yeah,
Type
no,
that
I meant like putting it in the computer, like.
Oh, in the computer. Oh, okay,
Sorry.
okay, okay. I can't remember.
I think it said on there. do this.
It'll probably give you a hint. I have the hints turned on so that it helps you type it into the calculator correctly.
But that's the answer.
But I can't remember if they may have just a special button that looks something like this with like a box, and then you'll have to fill in the box and then put the number inside. Usually that's what it'll do, something like that. So this right here would be our answer for that one. That's simplest radical form. So if that index is a 3, you need a group of 3. Does that make sense? Okay, let's try another one. Now this time, we've got the 3 on the outside, and we've got a 48. So let's start out by breaking up the 48. How can we break up 48?
2 and 24.
2 and 24. And how can we break up 24?
2 and 12.
2 and 12. She's going for the big numbers. And then
2 and 6.
2 and 6. And then
2 and 3.
2 and 3. Okay. So remember, we still have this 3 on the outside, right? That doesn't go away. And then we're doing the 4th root of, and we've got 2 times 2 times 2 times 2 times 3. How large of a group do you think we're looking for this time in order to escape from jail?
4.
This is a higher security jail. We need more people to help us get out. And you're right, we need 4. So we've got a group of 4 2s. So we're going to be able to take out a 2. And then notice that the 3 is still stuck in there. Now, again, we do want to go ahead and multiply this. And you can do that in your head if you want. But what do we get when we multiply this?
6.
6. And then the 4th root of 3. And that would be our answer. Okay. Getting a deep sigh there. I don't know that this is hard enough for a deep sigh like that.
Well, I'm just like,
I'm ready for Thanksgiving break.
I'm ready to come out.
You wonder why I was saying I would really like to let you guys go home. It's because I'm ready for Thanksgiving break too. But you guys said if you had questions, and I'm totally fine with that. It's part
You
of the
say
deal.
like go back. We don't need to do any homework. Oh, we're welcome. to
Yeah, I'm
do
sure, but unfortunately we
that.
can't.
No,
We've got to
we're
finish this
kind
up.
of
So,
like-
any questions on this one before we go on to the next one? Okay, so what happens if there are letters in here again? Variables. Well, let's start out with the number again because we're getting pretty good at those, I think. So how do we break up the 40?
2 times 20.
2 and 20. How do we break up the 20?
2 times 10.
2 times 10 and the 10.
2 times 5.
Okay, so that's as far as we can go there. So we still have the 2 on the outside. And this time we're dealing with the cube root of 2 times 2 times 2 times 5. And a to the 4th and b to the 8th. Now, if we need to, we'll write out the a's and the b's. But if we don't need to, let's try to avoid it. So look at the numbers first. What are we going to be able to take out?
2.
A 2. So on the outside, we're going to have 2 times 2, correct? On the inside, we still have that 5. So I'm just going to write it down there right away. Now we have 4 a's. How many do we need in our group for the a for an a to be able to get out?
3.
3 of them. So does it make sense we're going to be able to get 1 a out? And how many a's will be left inside? 1. Now I want to make sure, does that make sense to everyone? We had 4. 3 of them were used to get this one out. We still have 1 left inside. And again, it's division, right? 4 divided by 3 is 1 with a remainder of 1. If you think remainders. Okay. How about the b? We have 8 b's.
2.
2 b's will be able to escape, right? And how many b's will be left?
2.
2. That is correct. Is everybody okay with that? Concha is because she said the answer, but I want to make sure everybody is. We had 8. We're dividing by 3. So 3 goes into 8 twice, but you've got a remainder of 2. So the remainder of 2 is the 2 b's that stay inside. Okay. Now again, we don't want to leave our answer here, and you'll notice this looks a little funky right here, so I'm going to show you a couple things. We want to write 4, 2 times 2, a, b squared, and then if you're writing your answer by hand, I would probably leave a little bit of space here so that my 2 and my 3 don't get like accidentally connected or anything. And then 5ab squared. It's not like you have to leave a mile between them. I probably exaggerated a little bit, but I like to make sure that the squared and the 3 don't get mixed up. Okay. Does that make sense? So then this would be our simplified radical form. And sorry, I'm writing directly in the glares, unfortunately. Any questions? How do we feel about this one?
So better than the last
Better than the fractions?
Yeah.
Everybody hates fractions. Everyone feels better about this than fractions. Okay. So you've got 12 problems, and like I said, these don't take very long, do they? So I mean, you could probably get after them tonight and get them done if you really were motivated, or if you want to wait till Monday, that's fine too. Just try not to forget everything you've learned tonight before trying to do those. So